Hey guys, it's me Deepak again. So now we are going to solve an IMO problem. So the problem is IMO. Alright, it's IMO 2019. Question number 4. So the question is actually find all the positive integers. Find all the pairs of positive integers of k comma n. K comma n. So the equation is k factorial equals wait 2 to the power n minus 1 times 2 to the power n minus 2 and so on till 2 to the power n minus 2 to the power n minus 1. Alright, so I'll just give you a couple of minutes to try this question, so please pause the video and try this first. Alright, I hope you guys pause the video and try this. So the answer for this one is 2. Alright, so let's just give the solution. So the solution is that, well, let's take n equals 1. So then k factorial equals 2 to the power 1. Well, let's just write as 2, then minus 1. So that's just one term. If I'm going to go to infinite terms, well, it's just going to come 1 into 1 into 1 into 1. So the answer for this one is 1. So k factorial equals 1, then k has to be 1. So let's just write a short note like that. So when n equals 1, right, let's just put a separate bots. When n equals 1, then k equals 1 too. So now if I take n equals 2, then k factorial equals 2 squared minus 1 times 2 squared minus 2. So when we solve this, well, then we get, wait a second, yeah, so when we solve this, we get k factorial equals 4 minus 1, that is 3, times 4 minus 2, that is 2, times, well, we could just write it as times 1. So this is in the absolute form of a factorial, so you could write it as that k equals 3. That's not 3. Yeah, this is a bit like 3. Let me just erase it again. Right. So k equals 3. Alright, that looks like a 3. Now when n equals 2, k equals 3. Now you could also wonder, then what is n equals 3? Well, I'll do that for you guys too. So now when n equals 3, then k factorial equals, well, I'll just write it as 2 cube minus 1 times 2 cube minus 2 times, in this one we gotta do 3 terms, so 2 cube minus 4. So k factorial equals 7 times 6 times 4. Alright, so, well, this could not be written in the form of any number. That is, let's just take k itself. So we can write k as a definite number. So k that does not exist. Well, this is not what we expected. So what we're going to do next is that it's just a bit of like a formula. I don't know whether it's a formula or not, so just erase it. Alright, so let me write k factorial. Well, it equals to, it's n equals 3, right? So 6 times 4, 7 times 6 times 4. So what we're going to do is that next is we are just going to add another number. So it's times x times x. So now if you see at this one, well, this is a bit different. So k factorial equals 7.6.4. So when I take k, well, not k, n equals 3, well, I get something like 6.4, 7.6.4. So if I multiply with x, well, let's just say that this one equals y. So the next number, when n equals 4, I get another multiplication of numbers which consists of 7, 6, 4 too, because well, if you when n, not n, okay, let's just not put n in this one. So now if I take 1 factorial, 1 factorial is 1. The same time 2 factorial is 2. 3 factorial, well, that's it. Let's not discuss about it now. So when I increase the numbers factorial, I also get an increased number of the value. So if this is y, well, this is at, when this is at n equals 3, so it's y. When n is equal to 4, then at that time it's greater than y. So let's just take it as when n equals 4. So let's just take it a. So a is greater than y. So if I multiply x and multiply x again on the same side, well, I would never get k as appropriate value. I would never get it. Well, it does not exist too. I would never get that value. So if I prove that n equals 4, in that n equals 4, 7, 6, 4 exists, then I could say that k is not a fixed value for other than 1, 2 of values n. So I've just got to prove that. So let's prove it. So what we're going to do is that let's just take the same thing. So n equals 4, then 4, not 4, it's k factorial. K factorial equals 2 to the power 4 minus 1 times 2 to the power 4 minus 2 times 2 to the power 4 minus 4 times 2 to the power 4 minus 8. Alright, so let's just keep this term separately in another side. So I'm just going to consider these three terms. Alright, k factorial equals, well, if I take 2 common in this term, I get 2 cube minus 1. Well, then dot 2 cube, then 2 cube minus 2, then dot 2 times 2 cube minus 4. Right, so this is 7, and this is 6, this is 4. So as we know the pattern, that is 7 6 4, so we got a 7 6 4. So the rest of the other numbers, when n equals 5 6 7 and so on, well, we get 7 6 4. So the answer for this is, let me just rub it. Yeah. So the answer for this one is k in terms of k comma n, so it's 1 comma 1, then 3 comma 2. Alright, so this is our answer, and there are only two pairs of them, so this is the answer. Well, if you guys like this video, please subscribe it and share to your friends. Thank you.